So this video will go over section 2.4, which is on the periodic table. So we'll go over some basic features of the periodic table. Like the columns and rows of the table are not called like that. They are called groups and periods. The groups contains elements with similar properties in vertical columns. So the columns are called groups, and elements in the same group have similar properties. Periods are horizontal rows of elements, and they are counted from top to bottom of the periodic table. So the main group elements are found in the two columns on the right and the 6 columns on the left of the periodic tables. Their group number are numbered from 1A to 8A. Some periodic tables do not have this numbering with the letter A, but this is how I will identify those groups. I will identify them by group 1A, 2A, and then on the right side it will be 3A to 8A. So make sure you look at a periodic table that has this kind of numbering. The transition metal elements are the 10 short columns in the middle of the periodic table. And these are numbered 1B to 8B. It starts from 3B to the left, 4B, 5B, 6B, 7B. Notice how there are 3 columns that are called 8B. And then to the right, it's 1B and 2B. So these are called the B groups and the transition metal elements. And then there are the inner transition elements. There are the 2 rows at the bottom, separated from the rest of the table. They consist of the lanthanides and the actinides. There are no group numbers assigned to these. And in this course, we will mainly focus on the main group elements. We will rarely talk about the inner transition elements and only briefly talk about the transition elements. Our main focus will be on the main group elements. So this slide is summarizing what we just covered. And so the main groups elements are those first 2 columns on the left side and then the 6 columns on the right side. And notice how I ask you to identify the groups by their group number 1A, 2A, and then 3A to 8A on the right. The transition metals are the groups that are shorter and with B. So these are the B groups element. There are 10 columns like that. And the lanthanides and actinides are the inner transition metal elements at the bottom. So characteristics of group 1A and 2A. So we said that elements are in groups because they have the same chemical properties or physical properties as well. And so then we can talk about groups and their main properties. So group 1A are called the alkali metals, and you need to learn that name, alkali metals. The group 2A is called the alkaline earth elements or alkaline earth metals because they are also metals. And so for both of these 2 groups, 1A and 2A, their properties are they are soft and shiny metals. So they are metals, we knew that because they are on the left side of the periodic table. They're shiny because they are solid metals. but they're soft. They are not the hard metals as you usually think of. These are kind of soft. With a knife, you would be able to make a dent into the metal. They have a low melting point compared to other metals. They're still good conductors of heat and electricity because they are metals. They're very reactive. That's what distinguishes them from the others. It's that they are very, very reactive. And because of that, they are rarely found as single atoms or, unbonded. They are most often combined with other elements because they react very quickly. And in particular, they react with water to form basic oxide compounds. And those compounds are basic, which means they are alkaline. And that's why they are called like that, alkaline earth elements or alkali metals. So characteristics of group 7A and 8A. So these are on the right side of the periodic table. Group 7A are called the halogens. And they comprise fluorine, chlorine, bromine, iodine, and astatine. These are found in nature as diatomic molecules, which means two atoms of the same kind are bonded together to make a molecule. So they are found as F2, Cl2, Br2, I2, because they are more stable this way. So they are very reactive. Halogens are very reactive, and they react, for example, very well with the alkali metal from group 1A to form salts. And that's how you find them in nature more readily. Group 8A is a very particular group. They are called the noble gases. And as it says, they are all gases. So these comprise helium, neon, argon, krypton, xenon, and radon. So they are all monoatomic gases, which means that they are found as single atoms floating around because they are gases. They are not close to each other. They fly around as single atoms. And so they are very stable. That's why they can be gases and by themselves. Very, very stable. They're rarely combined with other elements. Carbon has an unusual nature. Carbon's ability to join with itself and other elements gives it a versatility not seen with any other element in the periodic table. So in nature, carbon is found, so elemental forms means carbon as an element by itself, not bonded to any other atoms, is found as a diamond. Diamond is made of carbon only, and the structure is very dense. It's a network of 6 carbon cycles, very compact. And that's why it gives this the nature of diamond. Carbon is also found as graphite. Graphite is really very different from diamond because it's black, it's crumbly. The structure is made of sheets of carbon bonded together. So it's cycles of 6 carbons bonded together in sheets. And because of that structure, carbon graphite is used, for example, in your pencil lead. The lead from your pencil is just carbon, and you can leave a trace with it because what you leave is a layer of carbon. That layer structure of graphite allows it to leave behind, some layers, and then that's why you can write with it. A more recent form of carbon was found in the 1960s by Buckminster, and he called this new structure of carbon that was found in nature the Buckminster fullerene. And these are made of 60 carbon atoms bonded together in a spherical form. So that's the carbon-only structures found in nature. So there are the names here that you need to remember. These are group 1A, the alkali metal, group 2A, the alkaline earth metals. I want you to notice here how hydrogen is not part of the alkali metal. Hydrogen is a non-metal, it's a gas. In nature, it's found as H2. It's a diatomic molecule, a gas and a non-metal. So it's not part of the alkali metals, even though it's in group 1A. Then you have the transition elements, which are all the B groups in the middle here, 10 colons. And then from 3A to 8A, you have the other representative elements or the main group elements. And there's no common names for 3A to 6A, but there is a common name that you will need to learn. For group 7A, they are called the halogens, and group 8A are called the noble gases. So let's do a learning check with this information. Again, you want to pause the video before watching the answer. So match the elements to the description. Metals in group 1A. So you have the options of SN and PB, C and SI, or CSI, GE and SN. So the answer is because it's group 4A and only the metals, and in group 4A the group is cut by the staircase, and you first have carbon and silicon, which are non-metals, and then the metals are only the tin and lead, because germanium is a metalloid. Actually, silicon is also a metalloid. So from that group 4A, you start with carbon, which is a non-metal. Then you have silicon and germanium, which are metalloids. And then you end with tin and PB, which are metals. So the metals from group 4A would be tin and PB. Non-metals in group 5A. Non-metals in group 5A. 5A starts with nitrogen, phosphorus, arsenic, antimony, and bismuth. The non-metals would be nitrogen and phosphorus, the two on top, because arsenic and antimony are metalloids, and then bismuth is a metal. Metalloids in group 4A, again, going back to group 4A, starting with carbon. Silicon and germanium are the two metalloids in there. Then tin and PB are metals, and we said earlier carbon is a non-metal. So that ends section 2.4.